Hello community! You ask me, hey, what is the latest state here to code agents? And you are lucky because just 4 days ago, OpenAI showed us here a beautiful new updated example. So I go with notation of OpenAI where they define here the class of an agent, and we will have a look. But before you have your question, so very fast, answer your question. You said, can also a vision language model constitute an agent? But of course, you just integrate an access to a stereo camera and you will activate here. You have your active vision language model, which will identify object in its environment. You have a beautiful control cycle, and almost every language model now is almost a vision language model. So no problem if you have the specific tools like here cameras, stereo cameras, and the system is trained. You have no problem at all based on the pre-training data that this system will work and will constitute an agent. Also a vision language action, yes, of course. You just have an active sensor array, and you have infrared, ultraviolet, LiDAR, radar, and you have a set of actuators. So you can move your little robot around in 3 dimensions, and the vision language action model learned this on the pre-training data here, especially then the fine-tuning data, how to control this. So we are in beautiful robotics. Also, we have in robotics our agents that work just great depending on the pre-training data and the fine-tuning. And then the question that I always love, can we build superhuman AI systems? Yes, of course. You just take here a vision language model and you add here access to an infrared sensor or to an ultraviolet sensor, and you have a superhuman agent. Because I, as a human, I cannot see the infrared spectrum and I have no ultraviolet sensor in my eyes. So here we have it, a superhuman agent. Thank you for your question. And now on we go. What are, according to the latest OpenAI literature, the key characteristics of an agent? Not gonna believe it. 4 points. You identify it. You have a model, a language model that you use, GPT-4 Omni Mini, for example. You have the instruction. This is more or less our system prompt that guides the behavior. And you have tools. This is a list of Python functions that the agent can call to perform actions or access external functionalities. And here we have it, our agent, the name, the model that you're gonna use, the instruction where you tell what you expect here from an AI system, from the agent, and the tools that the agent has access to. There is here beautifully the OpenAI cookbook, orchestrating agents, multi-agent configuration, routine and handoffs, and this is what I'm gonna show you. But here you have, of course, the link, and I leave the link in the description, and I leave you also the link to the complete Python notebook, so you get the complete code to download. Let's have a look, just understand here the basic idea. We say now here that agents, multi-agent system, each agent has a specific role and each agent has access to specific tools. So we have modular system, scalable system, conversational system, LLM systems, where each agent handles specialized tasks. And the conversation between a human and a multi-agent system can have seamless transition between the agents because the system will call all the agent specific whatever is needed. Now, you remember in my last videos, we had 7 agents, agent 1, agent 2, till agent 7, and they were here in a chain. Now you might ask, is a chain topology really the best thing? If we have multi-agent systems that interact with a knowledge graph, the answer is no, there are better configurations, but this will be the content of my next video. Anyway, what are our elements? What you should know if you're new to agents? Routines. Simple sequence of steps represent here as instructions to guide here the language model in fulfilling specific tasks. I will show you a routine in a minute. Then we have tools. Those are Python functions that perform specific actions, like execute a refund or look up a specific item in the database. We have function to schema conversion. This is a simple utility to convert your Python function into a JSON format, into a schema that a language model understands and can execute. And then we will handle tool calls. And this is simple, model can call specific functions during the conversation. And these functions are mapped to Python implementation that can execute the actions and return the result back to the conversation. 3 more terms, handoffs. By OpenAI, agent can transfer a conversation to another agent. We have multi-agent systems. Similar how a real-life customer support might escalate or transfer you to a different department. We have agent class. This is already showed you here. Provides a structure to define their agents, their instruction, their tools, and their model, the LLM that they interact with. And we have a beautiful multi-agent orchestration. The final code that I will show you allows multiple agents to interact within a single conversation. A routine is so simple. It is a system message that gives instruction to the agent. So you have in the agent, hey, you say, hey, you are a customer support agent for a specific company. Here are 3 points you should do. Ask the user, suggest a fix. And if the user isn't happy, hey, offer the user a refund. That's it. That's a routine. Agents are like workers, so they have specific tasks to do, and they use here specific tools, you know now that those are Python functions, to complete the tasks. For example, a refund agent uses here a function to look up here a specific item in the database of the company, and another function to process here a refund to the customer. So we have here a function that look up the item, here we have the number of the item, and then function execute a refund. Beautiful. So an agent will use this function that we have to define to complete the task. Now, this code here now allows you to simulate here a conversation where the user says something, types something, and the agent simply responds by following its routine. So we have here a function run full turn. This is the simplest, where we have a system message and some user messages. And this simply simulates getting a user input and calling the model. GPT-4, for example, or GPT Omni, Mini, whatever, you understand this. Then we have our messages appended and return a message. This is the simplest case, nothing is happening, just the agent asks here the user a question and you get here prepare an answer. Now sometimes, you need tools. No, the AI agent needs to use tools to answer here. So in a customer service scenario, the agent might need to look up the item in the repo or reprocess here a refund. So what we have to do, we have to map now the function into a schema. Schema is a specific format that the language model understands and let the model call those tools. So we have here a simple function to schema. We have the name, the parameters, the type, and the properties. And now the model knows how to call this function. So we see tool schema, function to schema, from execute refund, function to schema, from the function look up the item in the database of the company. Easy. And then when the model needs to call now a specific tool, it simply sends here a request like call the refund function. The code looks up here which tool to use and calls it with the necessary parameters, because maybe you have the customer name or you have an ID or you have the amount of items or whatever. So execute the tool call, a simple function. But now it gets interesting, because if now the situation needs a different agent, let's say a sales agent or a refund agent or whatever, now the current agent, and this is the beauty now with OpenAI solution here, can hand off now the conversation to another agent. So after placing an order, if the user requests now suddenly a refund from another item, the sales agent can now pass the conversation to the refund agent of the company, and the user can continue to cooperate here with those companies. So we have a refund agent, we define this agent, we give it a name, we give it a clear instruction. What is the task of this agent? We have here sales agent, help the user place an order, and then we can simulate very easily a handoff, a simple structure. And now we can more or less run this complete system. So the complete code runs in a loop, allowing the users to interact with the agents, and it switches between the agents based on the conversation flow. And this is all the code there is to it, and I hope you are familiar with this code. Now, this was the simplest example. Nothing was happening. We were just getting familiar with the terms. We have a look what's going to happen. So let's take now a little bit more complex example where we have 3 agents. Okay, at first we have a triage agent. This is the agent here at the forefront of our company. He's fighting here with the customer when a customer calls us. Hey, I'm absolutely not satisfied here. So we have here functions. our triage agent here has a name and instruction. Says, hey, you are a customer service bot for this company. Task 1, introduce yourself, always be very brief, gather the information to direct the customer to the right department, but make your question subtle, natural, and transfer it to the department. And what we have on functions, we have transfer to the sales agent, transfer to issue and repairs, and escalate to a human operator if the AI system says, no way I can handle this angry human. So you see, you define your function, you have your agents, you have your tools now. Transfer to sales agent here, transfer to issue and repair, this is here, and escalate to the human, you defined it here, and this is all there is to it. Now, the sales agent. Agent, we have the name, we have the instruction. You are a sales agent. Sell the user a product. Always answer in a sentence or less. Follow this routine with the user. Ask them about any problem. Yeah, you get the idea. And what we have, execute an order. Price should be in US dollars. Order summary, product name, the price. Confirm the order, yes, no, input. Order successfully, beautiful, or order cancelled. Okay. Transfer back to the triage. If everything worked out fine, call this if the user brings up a topic outside of your purview, including escalation to human. If there's another problem, there's always a fallback solution to another agent. And then our third agent is issues and repair. And you're not going to believe it. We have again the same schema. Agent, the name, all the instruction, all the function, all the tools that we can use here. They are defined now. We know what to do. We have a clear defined input-output schema. Great. But how do agents now interact? Now, we have a conversation flow. Then, as I showed you, we have tools or function calls. We have the handoffs and we have dynamic transactions. So have a look now at the main loop. What is the main loop doing? User input, the agent processing, the agent updates, and keeps the conversation running. That's all there is. And look, this is the code of the main loop. We start here with the triage agent. The agent at the front line, facing here the customer. And the user has something to say, beautiful. And we have now a run full turn with the agents, with the messages. Our agent has a response from the agent, update the current agent if a handoff has occurred, if a problem escalated, if you hand it off to a human or to another agent. And you have all the messages here in a beautiful list. Now, as you see, the real interesting function here is, of course, run full turn. Have a look at this. It is central to the system as it handles here the execution of a single conversation turn between the user and the agent that is here interacting with the user. It manages here the interaction by sending the messages to the language model, handling all the function calls, handling all the tools, and processing here the agent handoffs whenever they occur or whenever they are necessary. I give you the code. This is a rather simple code. Have a look at this. This is part 1. And this is part 2. Take your time, look at it. I will explain here what is happening in a conversation flow. Make it easier. So, the human user initiates the conversation, said, hey, I need help with a product that I want to purchase. The triage agent now handles here the first turn. So, triage agent is number 1. It is processing now here a run full turn, and it gathers the information from the human and makes a possible function call. Because either it transfers here to issues and repairs or whatever is the context, and we have an agent handoff. So the function call, transfer to issues and repairs, returns the issue and repair agent. The agent is updated. Now we have a new agent, not anymore the triage agent acting. And then we have here the agent continues now with the action. Processing continues with the while loop in the full run turn. And you have the communication now. Beautiful. Agent has a response, ask probing question, proposes some fixes, or maybe offer a refund. You have function calls, look up the item or execute a refund, and the conversation continues. And you see this is a beautiful loop, a beautiful circle. you can have another perspective if you want. Maybe this is easier for you. This is how it works in practice. So we have a user input and a message handling situation. The user message is appended to the complete conversation history. Maybe we start with 0, but maybe this user already called 10 minutes ago. And the message is as easy as a copy of the conversation messages is made to avoid modifying the original list during the processing. The agent interaction with the language model. The agent instructions are used as the system messages to set the context. I've shown you this already. The conversation history is provided now to our LLM, ensuring that the large language model has full context. And the model generates a response which may include content and specific function calls to solve this. Let's say we have a function calls, we have tool use, so if the model makes any function call, they are handled one by one. Each function call is executed using the execute tool call, which invokes the corresponding Python function. We define those functions, I've shown you this, and then an agent handoff. If the executed function returns an agent instance, a handoff occurs. The current agent is updated to the new agent that is returned, and a message indicating the transfer is added now to the conversation, to the recording. And then we have a loop continuation. And the loop continues as long as the model makes function calls, and once there is no more function calls, the turn ends and returning a response. However you would like to see it, it is a rather easy schema, and it's a beautiful new idea implemented by OpenAI. For my green grasshoppers, an explanation, another one here of the run full turn function, since this is the central element. So we have our agent, we have the messages of the conversation here, and the list of the messages that were exchanged so far, whatever happened. You have here a function logic now. You initialize the variables, you have the main loop, I showed you this. You convert the tools to a schema. You get the model's response, you have the client chat completion create that you know. You check for new function calls, you handle those function calls, you handle if there's an agent handoff, and you have a response of the system. If you want to see this in detail, no problem. I have here detail 1.1 and 0.2. Now you can read this also on a non-4K screen. Detail 2 here, get the model response, check for the function calls, and the detail 3 is finally the agent handoff and the return. Great. So this is it more or less. This is the new schema, 4 days old. Isn't it beautiful? So I ask now Strawberry, hey, what are the benefits, and can you give me a summary of here this new multi-agent orchestration as shown by OpenAI? And our little Strawberry comes back and says, hey, the benefits are modularity, we have dynamic handoffs, we have tool integration, we have a context preservation, and it is scalable. New agent and new tools can be added without significant changes to the existing system. This is nice. And the summary by our Strawberry is this run full turn function, as I showed you, this is crucial. This is where you should focus your attention. It is crucial that it orchestrates here the interaction between the user and all the different agents. It manages here the message passing, but careful, this is not the message passing from the graph neural network that we have over there. This is here the trivial case, so this is really just the conversation history. Then we have the model interaction, all the function calls, all the tools that we use, and all the agent handoffs. And yeah, if you apply this, you can build a sophisticated conversational system that is both flexible, scalable, beautiful. So this is a very nice system. Great. I told you I will give you here the complete code. So you simply go to OpenAI, GitHub, OpenAI Cookbook, examples, orchestrating the agent. It's a Python notebook. Beautiful, as you see, 4 days ago. Now all the errors are gone. Now it's beautifully working, and you can download here the complete Python notebook. You have here everything, even in smaller details. That's really beautiful examples in addition. But I hope I've given you here an introduction to help you a little bit with the new notion of routine and handoff here. And if you want, they also provide here then a sample repo for a swarm. That is an implementation without a coordinating agent. But I would say we skip this idea because in my next video, or one of my next videos, we will look here at a professional communication protocols between our agents that is automatically adapted to the specific configuration that we have between our agents. So in the easiest case, we have a chain of agents, but we will examine that we have different configuration in different spaces where we have different communication protocols that are necessary. And yeah, but this will be part of one of my next videos. So if you want to subscribe, hello, you are welcome. And it would be great to see you in my next video.